While geometric and trigonometric relationships can be used to find the resultant vector in many vector addition problems, the most reliable method to use is the component method of vector addition. It works every time and for any number of vectors. Suppose we have two arbitrary vectors a and b, and vector a plus vector b is equal to the resultant vector, vector c. The figures below illustrate the vector addition in terms of the components of vectors a and b. First, we resolve the two vectors a and b into their x and y components. Vector a has an x component in the positive x direction and a y component in the positive y direction. Vector b has an x component in the positive x direction and a y component in the positive y direction. We can now remove vectors a and b since they can also be represented with their component vectors. As long as we don't change the magnitude or orientation of the vector components, we can slide them along our coordinate system and arrange them in a tail-to-head fashion. We slide vector b sub x down so that it is placed tail-to-head with vector a sub x, and we slide vector a sub y over so that vector b sub y is now tail-to-head with that vector. Notice that vectors a sub x and b sub x are now collinear, as are vectors a sub y and b sub y. Let's now add the x and y components of the resultant vector c to the figure. Notice it has an x component along the positive x direction and a y component along the positive y direction. Now it's easy to see that the x component of the resultant vector is just equal to the sum of the x components of vectors a and b. Likewise, the y component of the resultant vector is equal to the sum of the y components of vectors a and b. This is the power of the component method of vector addition. We have shown the simple example here of adding two vectors together, but this technique works for any number of vectors. Since c sub x and c sub y are the vector components of the resultant vector c, we can use the Pythagorean theorem to calculate the magnitude of c. C is therefore equal to the square root of c sub x squared plus c sub y squared. To completely describe the resultant vector c, we also need to specify its direction. It is common to use the angle that is relative to the x-axis. Here we've called it theta. Since we know the magnitudes of all three sides of the right triangle in the figure, we can use whichever trigonometric function we want. Let's use the tangent function, so that tangent theta is equal to the opposite side c sub y divided by the adjacent side c sub x. Theta is then found by taking the inverse tangent of c sub y over c sub x. Let's summarize by developing a reasoning strategy for applying the component method of vector addition. Step 1. For each vector to be added, determine its x and y components relative to a conveniently chosen xy coordinate system. Be sure to take into account the directions of the vector components by using plus and minus signs to denote whether the component points along the positive or negative axes. As a useful bookkeeping technique, you may want to create a table of scalar values, where the vectors to be added are written in a column and their x and y scalar components are written in rows. See the table below, where we've shown the example of adding three vectors, a, b, and c, to obtain the resultant vector r. Step 2. Find the scalar x component of the resultant vector by summing the scalar x components of each vector being added. Likewise, find the scalar y component of the resultant vector by summing the scalar y components of each vector being added. Step 3. Use the x and y scalar components of the resultant vector and the Pythagorean theorem to calculate the magnitude of the resultant vector. And finally, step 4. Use the inverse sine, inverse cosine, or inverse tangent function to find the angle that specifies the direction of the resultant vector. This is the final section of Chapter 1, and it's fitting that we should end with the component method of vector addition, because we will apply this method many times throughout future chapters in the course.